Okay, guys, we're going to spend Monday's lesson as well on day 5 stuff. Day 6 is also day 5 stuff. So day 5 and day 6, it's the same material. We're going to spend a day and a half on it. Very important. And hopefully we can get into the lab and do some work. And if we can't get into the lab, I'll get us some pencil crayons because it's actually kind of cool to do some coloring with this one. So you guys want to bring some pencil crayons on Monday? Do some coloring? Okay. So think back to the function notation. Do you guys remember that? We start on the left oval, and then we do some function. Do you guys remember this? And you end up in this new world. What's the first world called? Domain. Good. And then you apply some rule or some formula or some function, and you end up in the ranch. I like that. You take an x1 and it ends up becoming a y1. And you could do this with an x2 and it would become some y2. Okay? And the formula for this, of course, would be y equals f of x. Remember, x is the input and y is the output. Okay, and that's what some of your quiz is going to be on when you take it home. Remember we did that stuff yesterday with the function notations, those algebra ones? You're going to do that this weekend, as well as the homework. You guys are going to be busy this weekend. Okay, so you're highlighting for me. Donnelly, did you get a pencil? You did. Okay, domain, set x. Okay. Range, set y. Some of you are really going to dislike this notation, but it's the way it goes. We can simplify it if we want. So domain is a set of all x, and this is how you write it like perfectly, like how a mathematician would write it. And you don't have to be as neat as this. I can show you some shortcuts, but all the domain is, especially for a graph or a function, it's just the left endpoint to the right endpoint. The domain is the horizontal. So there's a minimum on the left and there's a maximum on the right. So if you think vertically, your minimum would be on the bottom and your maximum would be at the top. Okay? So for domain, you're thinking left and right, and for range, you're thinking up and down. Okay? And these are for the most part, you have continuous relations that you have to do domain for, but occasionally you have discrete as well. Do you guys remember inequalities from junior high? You don't? What does this one say right here? X is less than A. So if you look at the graph, we're going to the left of A. Okay? What's this one? X is greater than B. So you're going to the right of B. Okay, look at this one. Y is greater than A. So we go up. So the graph is above A. Y is less than B. So the graph is less than B. Okay, so this page will help you. Let's take a look at this one. This one, how would you read this? X is less than B, but it's bigger than A. If you forget these symbols, see how it's a little pointy? That means it's smaller. See, this one is like bigger. The bigger side, it's X greater. Okay? So it means that the X is squished between A on that side, B on this side. X is in between. It's greater than A, but it's less than B. Okay? And then here's some notes. See these notes? So let's do one here. Let's make a number line. Let's call this 0 and 1. And let's put in some full dots. And then let's shade it. how would you write that? You would say x is less or equal 1 but greater equal 0. Because that's what the solid point symbolizes. Now watch what happens if I make a small change. Oh my gosh, where'd that go? Now you see that one I didn't fill in? That's a hollow point. So that means you get really, really close to 1, but you don't actually touch it. This is like 0.99999. So what would I have to switch to the inequality? It becomes this. If you have the equal to, you color it. If you don't have the equal to, you leave it hollow. Okay, let's do the first one. This is going to be hard for some of you. And it's very important, so please pay attention. I know some of you are kind of zoning out here because it's Friday and I've been going on for a while, but please just try to snap out of it. Okay, I'm going to try to pick an easier one first. Let's do B. B's actually easier. Okay, so here's some relationship. It looks like a half circle. I want you to think about which x values are acceptable for this graph. But you see how it's connected? So it's all the values between, but that's only true for the x. So for domain, which is capital D, you would write this. And some of you are going to really hate this. X is what? Less or equal positive 2, but greater equal negative 2. And then you put a comma. X is an element of the real. It's very confusing. It's very confusing. It's definitely on the test. So I want you to think about, if I was to shade with a pencil crayon, let me shade with green, you would shade this way. Would you agree? Because the graph, it can take on all the x values between -2 and 2. Does it have x values beyond -2 and 2? Is there any graph over here? So these are the only acceptable domain values, the x values. It's like you're trying to talk to a computer. This is what a computer scientist would have to program into to tell the computer to draw this graph. Okay, I'm going to do this function g of x, but only for the values -2 to 2. You'd have to, it's like you're talking to a computer. You have to be very explicit to the computer. Now this XER, I'll translate that into English for you. X is an element of the reals. It means x is a real number. In other words, it means it's continuous. Remember we talked in the real number system a few chapters ago? We're talking about like rationals, irrationals, integers, whole number. Remember all that? It just means it's continuous connected. It's connected. It's all the values. It's the fractions, it's the irrationals, it's all the values. It's connected. Okay, let's see if we can do the range. See if we can do the range. I'm going to color this one in blue. Which way do I color for the range? Remember the range is the set of all y. So which y values are acceptable for this graph? Anything between 0 and 2. Do you see how vertically the only acceptable values are from here to here? So how would you write this one? Y is bigger than 0, but less or equal to 2. And then you put a comma. Y is an element of the real. This is definitely important. In Math 20 and Math 30, you are frequently asked for the domain and range of functions. Frequently. Okay, let's try D. Let's see if we can do this one now that we've done one already. All right. I'll use black ink here. We go. Domain. What does a squiggly bracket mean again? Beautiful. Set. So it's the set of all x. That's the domain. Set of all x. So which x's are okay? Josh, please put your phone away. Which x's are okay? Good. -3. She's seeing it all the way to. Gorgeous. And I would recommend you take out a pencil, maybe a different color, and you shade the axis. So I'm going to use green for the domain. It's all the way from here to all the way to here. So this function, where does it live horizontally? It lives from -3 to 5. So here's what we can do, especially because those symbols with the inequalities can be quite confusing. I just want you to think left and right. What's the left? And what's the right? 5. And then put x in between. And then which way do you point the arrows? What does Beyonce always say? Huh? You don't even know Beyonce. I know Beyonce. Okay, and XER. Okay, let's do the range. Let's do this one in blue. Could we shade, what would we shade? From 3 all the way to 7. See where that function lives vertically? What's the lowest point for this thing? 3. And what's the highest point? Okay, so when you do the range, you're thinking bottom to top. So put the bottom first because it's smaller. 3 to 7. And then what goes in between? Very nice. And which way does Beyonce point? To the left, right? Oh, sheesh. Hush. All of you. Can you believe that? These guys, eh? He's listening. Okay, let's try A. Okay, for A, I'm going to show you what should be on the picture that's not, which is kind of confusing. There should be this right here. Can you guys add that for me? That arrow means that that graph is going to go on forever. Same idea. So this arrow indicates that it's going to go on forever to the left and to the up. If this thing's going forever up left, because remember the grid is 2 dimensions, right? So this thing's forever going up left. What about to the right? Oh, it stops. So it's finite. right here on this side. Like it's not, it is a word. It's opposite of infinite. It's finite, yeah. Yeah. All right. So when you write a infinite inequality, do you remember we had stuff on the left, stuff on the right? Well, now we're going to drop one of them. Remember, we pointed the arrows to the left. We had a left and a right, or a bottom and a top. Now we're going to drop one of them. Okay? So let's think horizontally first. Let's do domain for A. Okay, so what's happening for the x? Are all the x values to the left of 2 or to the right of 2? So here's 2, and all the x values are what? There's nothing to the right of 2. You see that? There's nothing over on the right side. So all the x values for this function are to the left of 2. So how would you write that with an inequality? X is what compared to 2? Smaller than 2. And is this shaded? So then you include the inequality, you include the equal, so it's less or equal to. Question? Okay, my bad, you guys. My bad. It's just because I have like serious vision problems. This is a 3. Sorry, that's a 3. But you get the idea. It's just a different number, okay? And then what do you put? Comma, x, e, r. Okay? You don't need the other side of x. Why? X is less or equal 3. Is that true what we got here? Is x less than 3? Yes. There's no left end point. It goes on forever. I feel your pain, Kylie. Range. Okay, how are we going to do this for the range? Let me color in blue. What's the lowest y value this thing could take on? Lowest. The graph dips all the way down here. And then, good, -1, good. Now, is the rest of the graph above or below -1? So then we shade this way. And do we ever stop shading? Okay, so all these y values are above, so we have to put which symbol? Greater or less? Greater. So put y is greater, or do we put equal? Yeah, because it's connected there. It's solid there. So greater equal to -1. Let me write it down for you. You wrote it like this. Like that. That's perfect. Yeah. That's okay too, because if you read it, y is on the greater side of -1. Yeah, definitely. So, do you guys want to see a shortcut on the domain? You'd write it like this. Curved bracket, -infinity, comma, 3, square bracket. It's a sideways 8. There's a little tick on there kind of by accident. That's an accident. Okay, now if we were to use that same notation for the next one, what is it? It's y is greater than -1. So you start at -1, so it means square bracket means you touch it, comma, and then infinite with no tick, oh dang, and then round bracket. The round bracket means you don't touch it, because you can't touch infinity. Oh, you can touch 3 because it's a square bracket. We'll come back to this notation later. Okay, so let's try C now. Okay, so what you're going to have to do is you have to put this arrow on here. Okay? Put the arrow on there because it is going on forever, but you might not recognize that if you don't have the arrow. Now domain, what would you say for the domain? What's the biggest x value this thing takes on? 5, right? And then the rest of the graph is to the left. So what would you say about x? All the x values are what compared to 5? Smaller. So how do you write that? Little arrow pointing to the x. And you include the equality because there's it's shaded in there. Okay? And you know what, guys? I'm going to be lazy. XER. I'm going to be lazy. And what about for y? What's the highest y value? 2. And then all the other values are lower or greater than 2. So y is less or equal to. Now I'm being lazy with the YER. Okay? So you can be a bit lazy if you want. I won't kill you on that. Well, I say we finish this off. Determining the domain and range of the graph of a situation. All right. The graph shows the number of fishing boats N anchored in an inlet in the Queen Charlotte Islands as a function of time. Identify the dependent and the independent variable. So dependent, of course, is y. Independent, of course, is x. Why are the points on the graph not connected? Because it's discrete. You can't have a fraction of a boat. You can't have a fraction of a boat. The boat, if you had a fraction of the boat, it might sink, and it will no longer be a boat. So, because this is discrete, we're not doing this. See this page? We only do this stuff for when it's connected. When it's discrete, we just make a list. So for the domain, which x values are okay? This looks like 9. What's this one? 10. And this one is 11. 12 and 13 we have here. 12, 13, 14 and 15. And 16. And you're done. Okay, so those are all the x values for this relationship. And the range is going to be all the y values. So it looks like we have a 25. They're going up by 2s, yep. So 25, this one is 10. And then 8, 6. 6 happens twice, right? Yeah. You don't have to put 6 2 times. Don't repeat elements. So you don't have to put 6 twice. What's after 6? Oh, 10 again. Do you have to put 10 again? No. And then we have 11. And then we have 15. Do your squiggles have to be perfect? Look how crappy that one is. Okay. Okay, let's take a look at the next one. The graph shows approximate height of the tide as a function of time. Identify the dependent and independent. So dependent is always y, so we have height. And independent is the x, that's time. Why are the points on the graph connected? H and T are continuous variables. Continuous variables. Sorry, I'm a bit rushing here. Could you take half of a meter? A quarter meter? You could do that. Could you do half a minute? Quarter minute? So these variables are continuous. So that's why it's okay to connect. So if it's continuous, you do not make a list. You do not make a list for continuous. For continuous, you have to provide an interval. So for x, what kind of interval is this for x? From 9 to what? 13, 14, 15, 16. And I'm actually not going to put x there. What am I going to put? What variable is x? Time. Okay. And vertically, what's the highest point vertically and what's the lowest point vertically? Looks like 1 point, what is this? 1.5 is the highest? And what's the lowest? 0. It's just above 0.8, right? So 0.9. So I'm just going to write on here, you know, bottom, top, left, right. You should, yeah. And another assignment. Plus the take-home quizzes. So I really gave you a lot of work today.